For nearly 80 years, it's lived almost entirely inside equations, a ghost in our cosmic backyard, a vast theoretical shell of a trillion frozen bodies marking the final, lonely frontier of our solar system. A domain so vast, so dark, and so distant, we could not see it. We could not measure it directly. We were taught to picture it as a silent, mostly empty void. But what if it's not? A telescope sensitive enough to register the faintest whispers of infrared light has turned its mirror outward toward that frozen frontier. And the initial signals it's sending back suggest that the most distant part of our solar system is not empty at all. It's not a graveyard of cosmic leftovers. It's a library. And what we're learning to read could tell us where we came from. This is the story of how the most distant region of our own solar system stopped being a guess and started becoming a place. To understand what's unfolding, we have to travel to the edge of everything we know. In 1950, a Dutch astronomer named Jan Oort was studying the orbits of long-period comets. He noticed something strange. They weren't coming from the flat plane of the solar system, like objects from the Kuiper belt beyond Neptune. They were arriving from every possible angle in the sky, above, below, from all sides, as if they were being knocked loose from a giant sphere that completely encased us. Oort proposed this shell was real, a colossal cloud of icy bodies, leftovers from the solar system's formation 4.6 billion years ago, orbiting the Sun at an almost incomprehensible distance. This became known as the Oort Cloud. Let's talk scale, because that's where the mind begins to bend. The nearest star, Proxima Centauri, is about 4 light-years away. The outer edge of the Oort cloud is thought to stretch more than a quarter of that distance, maybe even halfway. But it's not a dense cloud. The objects inside are separated by millions of miles. If you were inside it, you'd see nothing but empty black space. The silence would be absolute. The sun would be just another point of light in the sky, barely brighter than the stars around it. For 70 years, this was the picture. A theoretical, dark, and fundamentally inert sphere. We inferred its existence from the comets that fell out of it, but the cloud itself remained a ghost. The most important place in our solar system that no human eye or telescope had ever truly observed. Until now. Enter the James Webb Space Telescope. This isn't just another telescope, its instruments are designed to see in the infrared. This is the key. Cold, distant objects that emit almost no visible light still have a faint heat signature. For Webb, the darkness of space isn't truly dark. It's filled with the faint, infrared whispers of the oldest, coldest things in the cosmos. This makes it the perfect instrument for an impossible task. Not to take a picture of the Oort cloud, it's far too vast and sparse for that, but to do something much more clever. To wait for a messenger from that unseen kingdom to draw close enough, and then, for the first time, to read its chemical mail. And in late 2022, its detectors locked onto something that had no business being where it was, doing what it was doing. Its name is Comet C 2014 UN271. Most people call it Bernardinelli-Bernstein. Buried in archived survey data, astronomers found an object whose orbital calculations didn't fit anything they expected. The nucleus of Bernardinelli-Bernstein is roughly 85 miles across. That is not a typo. 85 miles. Hale-Bopp, the bright comet from 1997 that was considered enormous, had a nucleus around 25 miles wide. Halley's Comet is barely 9 miles across. Bernardinelli-Bernstein is bigger than most asteroids. A single object, falling toward the sun from the Oort cloud, the size of a small state. If something this big exists out there, it almost certainly is not alone. As Webb turned its golden mirror towards this giant, it wasn't just looking at a dirty snowball. It was eavesdropping on the past. The comet was still over 1.2 billion miles from the sun, well outside Saturn's orbit. It was so cold that water ice should have been frozen solid. There should have been almost no activity at all. Instead, Webb detected something unexpected. Carbon dioxide outgassing from the nucleus. The ice was bleeding. Slowly, quietly, In the deep cold beyond Saturn, the comet was venting frozen gases that had been locked away for over 4 billion years, gases that were present when the solar system was first forming. Webb wasn't just looking at a comet, it was reading a chemistry record older than anything in the inner solar system. This was the pivot on which our understanding turns. The emissary from the Oort cloud was not inert. It was a time capsule, and its contents suggest the Oort cloud isn't a chemically dead wasteland. And when Webb pointed at another long-period comet, C 2017 K2, its spectrometer found not just carbon monoxide and dioxide, but organic compounds. Let's be clear, this is not evidence of life, but it is evidence of the ingredients for life. These are the same kinds of raw materials that scientists believe were necessary for life to emerge on early Earth. What that means is still being debated, but it implies the Oort cloud isn't just a passive storage container. It's a record of a different stage in the solar system's birth. We are no longer studying a generic frozen graveyard. We are studying a stratified, layered, chemically complex region that holds information no other place in the solar system can give us. So, what does all of this mean? First, it redefines the Oort cloud. It's no longer just a gravitational boundary. It is the guardian of our system's pristine, primordial chemistry. For 4.6 billion years, while the inner planets were baked and pummeled, the Oort cloud has kept a perfect frozen record of the starting materials. It's the solar system's control sample. Second, this gives powerful support to the idea of cometary delivery. The theory that key ingredients for life, both water and complex organic molecules, were not originally from here, but were delivered to the young Earth by a constant rain of comets and asteroids. Now, with Webb, we have essentially analyzed a pristine package from the cosmic warehouse and confirmed that it is, indeed, packed with the very goods needed for life. Imagine the early Earth, a hot, sterile world. Now imagine it being bombarded for millions of years by comets like these. Each impact is a delivery of water ice and a rich stew of organic chemicals. Over millions of years, Earth's oceans become a primordial soup, not because these molecules magically formed on Earth, but because they were delivered, ready-made, from the outer solar system. This moves the starting line for life. It suggests the chemistry for life doesn't begin on a planet. It begins in the cold, dark clouds between the stars, where these ices and carbon molecules first form. The leftovers from a new star's formation are flung outwards to create an Oort cloud. The cloud, then, isn't the creator of these molecules. It is the guardian of a precious, pre-existing inheritance. This discovery doesn't close a chapter. It blows the book wide open. We now believe most other stars are likely surrounded by their own Oort clouds. We've already seen hints of this. In 2017, the object Oumuamua passed through our solar system. In 2019, a second visitor, 2I/Borisov, did the same. These were emissaries from the Oort clouds of other stars. But Webb's observations raise a different question. If interstellar objects pass through our solar system, how many get captured by the sun's gravity and trapped in the Oort cloud? Some models suggest the answer is significant. The cloud may be peppered with bodies that did not form around our sun at all. If that's true, then every time a comet falls from the Oort cloud into our skies, there is a chance we are looking at material from another world. Not metaphorically, actual physical material, born in the gas cloud around another sun, that drifted across light years before being caught by our star. This is what astronomers mean when they say the Oort cloud is not empty. They are saying it has become a place with structure, with history, with a biography. A place that holds questions we didn't even know to ask. What comes next is going to be slow. But observatories like the Vera C. Rubin in Chile are expected to find thousands of new long-period comets. Each one will be a candidate for Webb to study. We will be making maps of a place no human will ever physically reach. Honestly, this is the part that gets to me. James Webb did not give us a photograph of the Oort cloud. It will never give us a photograph of the Oort cloud. What it gave us is something stranger, and ultimately, more useful. It gave us a way of listening, Each comet that falls toward the sun is a voice from a place we will never visit, carrying a message from the deep past. Webb is teaching us how to hear those voices, one at a time. And the message coming back is simple. The space between us and the next star, the space we used to think of as a void, is full of history. The Oort Cloud is not empty. We just had to build a telescope sensitive enough to prove it. What do you think is the most profound implication of this? Let us know in the comments below. Thanks for watching, and I'll see you in the next one.